Good afternoon, everybody, and thank you for the opportunity for Mitch and I to present subsurface utility mapping and how the new technologies are augmenting our traditional utility locating using especially radar tomography. Today we want to talk about a short history for underground utilities, and for us in the Boston area, being a Boston-based firm, we have a long history of mapping above and below ground. So we look to our peers for some of the best practices that we've had, and some of the work they did is astounding because it really shows the direction that we're headed today in how we map and make a digital twin of the environment we're working in. The history of utilities is often forgotten that it goes back so many years. And if you look at the history, some archaeology friends of ours have provided some graphics, and some ancient civilizations have had utilities that were thousands of years old. So uncovering this history is an enormous task. And how we document and locate these utilities becomes tougher and tougher as the years go by. The other part of history that many forget is that some of the infrastructure that we have in modern times began a lot. It's not just a few years ago. It actually goes back into the 1800s. And if you look at some organization like Pacific Scientific America, we actually have some great documentation of major projects around the world. These are projects from most North American cities where they were building the infrastructure that we rely on today, including subways and tunnels and major aqueducts that provide us the water and services that we rely on today. And so we often forget that these have been there for a very, very long time. The other graphic that we have on the right side is actually from New York, the Public Library, and you see this isometric view of a 3D environment, and that's down on Wall Street. So turning back the history in these streets is very, very challenging, and it takes every bit of our skill to be able to uncover this history. For us in the Boston area, we have a long history of burying utilities. We know that, for example, the Boston Gas began in 1832, and we often hear the cliche about the utility corridors are crowded and getting very congested. However, we know these have been very congested since the late 1800s, and many of these systems remain in place today. So uncovering not only the existing infrastructure, but the older infrastructure that could have been buried is important to us. What we also admire from the history is some of the artistic detail that was done in the survey work for infrastructure. Today we pale in comparison from the presentations we see, and this graphic is a street that we're currently mapping in the Boston area for an energy company. But the documents we have are stunning in their detail. They're based on survey, so these, even though they're historic legacy documents that are archived, they do provide us with horizontal and vertical position of critical infrastructure. On the other hand, we do find a long history of aging infrastructure from the late 1800s, and not given that some of these systems are very challenging for us to uncover. For example, an old gas pipe will trace much better than a current plastic gas pipe. So for us, finding this infrastructure and getting the complete picture of the underground is very important. When we look at some of the records, this one is actually from the Mass Transit Authority when they were building the first subway system in North America. And in Boston, we actually look at these records, and there's some amazing stories in here. They talk about the need for having accurate design. They talk about asset owners' plan being imperfectly kept and that they needed to do very good surveys above and below ground to create the construction documents for successful projects. A lot of the rhetoric that we hear today still existed for these guys back in the 1800s. And anybody that visit Boston will know some of these places. For example, this is on the Freedom Trail. And when you look at the 1800s, there's not only the infrastructure of protecting utilities, but there's also subway systems. And that Freedom Trail actually has a tomb buried under the sidewalk. So when we're applying our systems today, it's not just about mapping utilities, it's also about mapping critical infrastructure. Part of the work today is creating awareness for us. So at DGT, we're always trying to create the awareness and make sure that there's some knowledge of the past projects. There's a lot of surveys done in our work. There's studies done that document the return of investment. And we keep on trying to share that information. But of course, a part of that information is not just about mapping underground infrastructure, but it's about underground damage prevention. Again, in Boston area, in our local area, we find one of the first documented underground damage. This was a contractor who damaged a gas line in 1897. And just to give you an idea, we actually modeled and scanned the above ground for this area. And when you can see that the below ground infrastructure was very dense even in 1800s. So today it's a lot easier for us because we have remote sensing technology that help us. And Mitch is going to explain how that technology applies to creating some very good visuals for our clients. Of course, one of the big questions that comes up is the damage claim by project overruns, damaged and tarnished reputation on projects. And a lot of times when you look at some of these major projects that have gone sideways, it actually can be attributed to the lack of planning for underground infrastructure. So, for example, I worked in the Sydney Light Rail in Australia, and that infrastructure was problematic because there was so many underground unknowns discovered during construction, similar to the 405 in California. So we know this is a global issue, and the best way to manage the risk underground is to map it before construction begins. Of course, we often know that underground infrastructure and the investigation is not always taken seriously. This is a photograph I took on the left in Dublin. This is O'Connell Street in Dublin, and you can see the pipe locator inside what we call the Irish F-150, which is a wheelbarrow. So obviously this team is not as thorough in their investigation as they should be. And of course you see these pictures. This was from San Francisco a number of years ago, where underground investigation should not look like that. When we get into the subsurface plans, there's a lot of different types of plans, but we still love using the old documents to verify our current documents, and they give us a very good validation of the systems. And of course, some of this, like the one on the left, this is right next to Harvard University. They not only did beautiful plan and profiles, but they took the time to add a mermaid and a little goldfish inside in the bottom of this one. So we think it's the work is there. We believe that it can have some charisma to it, and we see this as a growing industry. But of course, a lot of what we've lost in translation over the years is that we didn't do as-builts. Of course, we look at the digital archives and we see many of the old asset owners did spend the time to have survey crews go out and map the underground, and that's what kept these documents so reliable. When we get into today's environment, these documents become very important. So it's not only taking legacy documents from our peers and other companies that may have done survey and mapping, but it also goes back into the early days. The one on the right-hand side is the original streets that have the sewer connections. And of course, with many organizations looking how to minimize crossbores because of directional drilling, if you look at the old legacy documents, they showed us the way where they surveyed up the existing infrastructure, they plotted it, and today we XREF these documents in to become very reliable for our work. And this is the difference between a typical survey done for other purposes on the left, and this on the right side, we're looking at a documentation for the same street 20 years later, but we're actually adding in all the subsurface information we get from our remote sensing. And this is really important because using legacy document, while it's very good, we do note that some of the asset owners have stopped updating our records. So we see that on the left side here, we have the last update and revision to a telecom owner's documents was in 1998, and obviously we know that by 2022, there's a lot more utilities added into these streets. So how do we find this information? It becomes very challenging for us as practitioners. And modern GIS doesn't always solve the problem either. This is a GIS information XREF in the background. And the middle of the street is where the asset owner believes the water line to be, but we actually found one on the top and the bottom side of the street, which is nowhere near the placement of what the existing conditions look like. Now, this document is very interesting because this is a project I did in St. Louis a number of years ago, and it was for a hospital project. What was interesting about this project is the original survey firm that were doing the mapping had compiled the utilities, but what we really found was there was a missing 20-inch gas pipe and a missing 6-inch gas pipe around the project that was not documented, it was not on the asset owner's records. So how do you find these type of critical infrastructure before construction? And you definitely need to find it in the early stages of design to mitigate any of the impacts and the safety concerns on major works. So subsurface utility mapping is something that's we focus on, and applying the survey tools that we have in current day practices have made it very, very easy to do this. So we're doing LiDAR scanning and sighting chambers, and that helps us move out of a 2D environment into a 3D environment. And over the years, how do we turn back to history and understand really what happens in these streets? And for us, this is a typical deliverable. This is a document that's done, color-coded. It's American Public Works color coding. All of the lines are annotated to conform to the ASE standard for 3802. And this is typically what we do is make sure that every line is represented not only to its annotations for reliability, but also for a number of conduits. Asset owner information is added where possible, and it completes the picture for the underground. But it's not just the linear projects. We also find vertical projects. This is actually in the downtown metro area, and the foundation contractor would have actually damaged the existing infrastructure in the street just because of the soil nails they were punching out for holding the foundation elements in place for a tower. So today we look at subsurface information. We all know about building information modeling, but subsurface information modeling is a part of our current workflow, and moving from a 2D environment using these traditional tools such as pipe locators and GPR is important to us, but it's also important to take this data and be able to extrapolate and make the complete picture. Now, it's not easy to do. If you look at the Sharp 2, there was a comment by Dr. Ray Sterling. And how do you easily map the infrastructure? Well, the conclusion is there's no black box. There's no magic wand that can uncover all this information. So it's very important to apply all the appropriate technologies in unison to complete the picture for any project, be it major or small. One of the concerns for us as practitioners is how do we work in the travel lane. So as the years go by, it gets more and more dangerous for practitioners for us. And so we see the danger of being out there fixated on our devices and walking in traffic lanes is a very high risk to us. And I think that is common to the US and to Canada, but in other countries maybe they close the lanes and do work at night. But unfortunately, too many of us are out there. And what we really like to do is find the new technologies and explore ways that we can map in the travel lanes without the impact and the risk.
All right, so I'm going to get into talking a little bit about ground penetrating radar and how we incorporate that into our subsurface utility maps. This here is a picture of our new ground penetrating radar setup. We were collecting some data here in Pittsburgh. These are on the famous Three Sisters bridges. You can tell just by looking at them, these are downtown, they're very busy. You don't really want to be out on the middle of those bridges unless you've got traffic control, which can be expensive and disruptive. So this is definitely in a place where you want to be using a drivable rig, a mobile mapping unit. So just introducing GPR again for those who aren't as familiar with it. It's a way of sensing, a remote sensing technology using electromagnetic radiation. So it's just radio waves that we're pulsing into the ground. They bounce off an object or a pipe or whatever you have, and as you pass over it, the time it takes for the signal to hit the pipe and come back to you changes, and we get this really characteristic hyperbola shape. And that's right at the top of the hyperbola is where we'd pick the top of the pipe. The other aspect of GPR that we have to think about is the frequency. So really high frequency waves don't penetrate as deep, but they can sense smaller things than a really long frequency or long wavelength, low frequency waves, which can penetrate deeper into the earth, but they aren't quite as don't have quite as much resolution. There's the usual way we see GPR used is with these push carts, and they're very useful. They definitely have their utility, and especially in places where it's hard to fit a bigger unit. And the way I've thought of it is you kind of walk back and forth with the 2D cart, and you get different slices of bread, which represent the subsurface. With our 3D unit, we are getting slices. So we're getting many slices at once. Our current unit is a 24-channel system, so we're kind of getting 24 slices every time we go, but it also is a multi-frequency system. So the analogy I've got is not just slices of bread, but different types. So you've got sourdough and rye and whatever you need, and we're all collecting them simultaneously. If you want to compare them, if you have to compare, there is more and more demand for this type of work, especially in the roadways. And if it's in a roadway where we want to be safe, we want to be fast and efficient in collection, and we don't have to worry too much about access and space, for example, like in a bike lane or a sidewalk, then we can see the amount of data we can collect quickly. So with our system, on a slow day, conservatively, we can collect about 10 miles of data, and that's with our quality parameters kind of maxed out. With 24 channels, that's 240 miles of GPR data. Now, if you wanted to do that with a 2D cart, you're talking about 10 days of no rest, just walking to get the same amount of data. But of course, it wouldn't be quite exactly the same because we are collecting with the 3D system multiple frequencies instead of just one. So it's still not quite apples to apples, but you kind of get the idea. I'm going to show a little bit of GPR data over the next couple slides, and just keep in mind the way that I'm slicing it. So if you think about the roadway and the data that we collect behind the system as a loaf of bread, we have depth slices, which are slices kind of from the top of the loaf going down in that orientation. Cross sections would be crosswise, lengthwise along the bread, the way you would not make a sandwich. So the opposite way, lengthwise, you'd make a sandwich. Just kind of keep that in mind. The top of the loaf is the surface of the roadway. Again, I'm talking about frequencies. We have a depth slice on the left here, and it's right at the surface. So you can see
some manhole covers. They are those circular features, and the metal in the manhole cover really rings with the GPR, so you should be able to see it. We have high frequencies at the surface, and we were able to even resolve the paint on the ground, so you can tell it's a left turn lane there. There's other easier ways to find out if it's a left turn lane, but this is one way. On the right is a cross section, so we can see all the way down to about 8 feet, which is quite deep for Boston with the soil that we have there. 8 feet's pretty deep for us, and that's our lower frequencies penetrating deep down, and we can see the top of a pipe with that, and I've traced it out in purple. So the benefit of this is we're collecting all this data simultaneously, the high frequency and the low frequency. So what is the value of including GPR in our subsurface utility maps? Well, the first thing is safety. So this is a screenshot from Google Earth, from Street View. This is on Long Island, a job we had recently. And you can tell you really wouldn't want to be in the middle of this intersection. It's extremely busy. You'd either have to do it at middle of the night, you'd have to get expensive lane closures, etc., police details, that sort of thing, or you could collect it with a mobile mapping GPR system, which is what we did. We can get fast collection. So this is an example where we hooked up our system to an ATV, and we were able to ride around in the park. This is in Cambridge, near Boston, and we collected all this data in one day. You can see the tracks we took with the ATV, trying to cover all our bases and where the trees were, we had to go around them. So the other advantage we have is confirming location. So with the GPR, we don't see everything, but we see a lot of things. And even when we don't see the pipe, we often see trenches. And nobody's out there digging trenches for exercise, right? So if you see a trench with the GPR, you can be pretty sure that there's a utility in there, even if you don't actually see it with the GPR. So these are all color coded based on what utility they are. And some of these we didn't see the pipe, but we did see what we know that from other techniques what it should be. So there's some electric pipes there in red. We see the trench, and the trench is infilled with either different material, or it's a little denser or a little less dense than surrounding material. So you can see it pretty clearly and trace these things with GPR. We can determine depths with GPR really well. This is something that's a strength of it for sure. When we see the top of the pipe, we're able to trace it in the cross section. So again, the top of this section here is the roadway. We're going down into the earth 4.5 feet. We see a gas pipe, and we're able to see the top of it very clearly with the GPR. This is my favorite sort of thing we find with the GPR. Every road we've been down, no matter how many legacy maps, no matter how much institutional knowledge or pipe locating we've done, we always find unknowns. And this is an example where we had, despite all that previous information going into our background map, we didn't see this pipe. This is actually 2 pipes next to each other, crossing the street, and then taking this very interesting 90-degree turn. There must be some good reason they did that, because it's not very efficient, but nobody knew before we went out there and scanned it with the GPR. So when we integrate the GPR into our subsurface utility maps, the way we go about it is we try and think about the underground as like, well, the way I like to think about it is this block of Swiss cheese. So each slice has its own different strengths and weaknesses, which are represented by these holes, right? So we layer them on top of each other, and we hopefully get a better approximation of the true subsurface information. But GPR is not magic. If anybody is out there telling you that you want GPR, it'll find every pipe, it'll find the metal, non-metal, everything in the earth, they are lying to you. You can't see everything. It is not replacing any of the previous techniques, it's augmenting them. And the 3D system is not replacing the 2D pushcart either. It's just augmenting it. It's better for certain situations and worse in other situations. So the way our workflow goes is we start with our legacy maps, we add our institutional knowledge. This is decades of being used to the way that the construction goes in the particular region you're working in. All of the client information, all the asset owners, maps, everything we can amass. We add that all together, and we add our traditional EM pipe locating data. And then we use this map in the background to augment the way that we interpret the GPR. So an example of this is one of the best examples I have. In Cambridge, we had all this information in the background. We collected our GPR data, and what I found was these interesting rectangular pits, which are located here on the top image by these purple circles. So each one's about 1 foot by 2 foot wide, and they're all regularly spaced at 12 feet. If I only had the GPR, I'd really have no idea what was going on here. But because we have these background maps, we are able to see at the bottom here, the background map with and without the data on it, we're able to see that these pits line up really well with some old legacy data that told us there was an abandoned gas pipe there. So without the GPR, or without the background map, we would have no idea what to do with the GPR, and the GPR is confirming this location, which we only had from a legacy map, and we didn't know for sure was even there, but we're able to see from a different angle and kind of build up our knowledge of the subsurface. So this is this is a movie of going through the depth slices, and you can see each one of these lines represents a utility that we're able to color code based on the type, and the type is based on our previous our existing maps. So the blue being water, the orange being telecom. And something that's really striking is this purple utility at only a foot and a half deep, crossing diagonally across the street. And purple means unknown. So we really had no idea this was there until we pulled the GPR across it. With that, I'd like to invite any questions and thank you all for your attention today.
Great presentation. Very interesting to see some of that archival material. We've got quite a few questions here, so I'm just going to jump into it. First question. Very important work about archiving digital twins. I love the work of Frederick Law Olmsted did in 1878 on green infrastructure project for the city of Boston, the park system, which he christened the Emerald Necklace. How will that historical data be connected to archiving digital twins?
Well, there's some great information in the Boston area, and what we do is we actually dip into the archives when specific projects impact that. We don't see anything for a master digital archive or a citywide digital archive in recent years. And because of some of the things like we saw in the previous presentation with New York, there's a lot of privacy issues with some of the asset owners. So we don't see any depository of information that's open to the public where you can actually see all of this data integrated. And as some of the people have asked in the chats and questions and answers, we actually do all of this research for specific customers and clients across a lot of different disciplines. So we do transportation, private institution, and energy clients, for example. But a lot of this information is held privately, is not shared publicly. And it's not our right to be able to share all of this information as a private entity. So unfortunately, you don't see this holistic approach to having what Neil and some of the folks are doing in the UK to have this national database available and have everybody be able to tap into it and understand the underground workings and how that relates to their own local environment.
Thank you very much. I would ask the question that comes in marked as from Sustainable Coburg. Your second question has many parts to it. Would you mind rephrasing that one and putting it in again? I'm going to return to that, but it's got about 3 or 4 different questions in one. So I'm going to move on to another one of the questions before that one. Next question. Are there other technologies in addition to EM and GPR that you foresee becoming important for underground locating?
The thing that I think is most important to augment our GPR right now is improving navigation technologies. So we're talking to some people about this. There's advancements going on, but a lot of this work has to be done in urban canyons and cities. And if you don't have extremely good location data and navigation at driving speeds now, because we're talking about pulling it behind the van and collecting in the street and collecting a lot of data quickly, this stuff has to be done live. So there is advancements going on with that. I think that's the next step to make sure that this is scalable, what we're doing for really important dense areas, not just on streets where you have rural streets where it's a little bit easier to do it, but in cities, in really like spaghetti underground situations. These are important. We have to be able to collect data quickly there.
To add to Mitch's comments, there is other remote sensing technologies that can be used for mapping the underground. So for example, we use terrain conductivity and some of the other geophysical tools, but it's all dependent on the site conditions. So for example, when I work on a pipeline for somebody like TransCanada in Montana, Wyoming, those technologies can apply, but in a very dense environment with a lot of electronic interference, we're not allowed to use a lot of technologies because they don't yield very good results. I think there's some research in the UK coming that may have some new technologies that practitioners have not seen in the field today. And obviously anything new like that will be a major step forward. Of course, there's always the hurdle of, adopting new technologies can be very expensive. So as practitioners, we rely heavily on what we have in EM and GPR for the work we do today.
Thank you very much. I'm going to make an attempt at one of the first questions here.
I'm taking this to be a question about convincing people the value of what we're doing. So, well, adding GPR to what is typically done with utility mapping, is more expensive on its face, but there's a lot of costs to be saved. So in terms of hopefully we'll be having to do fewer test holes, at least be able to target the test holes we're doing more accurately. So you're saving on just sort of every time you open the street, it costs a lot of money in terms of closing lanes and disruption to traffic and traffic control. These are expensive things. And of course, the amount of data that we're collecting is so great. When laws come in, like we're looking at new regulations here in Massachusetts for more of this sort of data needing to be collected for projects. So if you're going to be having to do this sort of work, no matter what, this is the way to do it fast and to do it much cheaper than it would be with other traditional techniques. So that I think those arguments are really easy to make, but people do need to be convinced because there's some momentum if it hasn't been done that way before and it's been sort of working. Maybe we have to convince people that it's not working quite as well as it could be, I suppose. The other question that I see from same person here, what advice you have to not go for bells and whistles? I think that's a really good question because a lot of excuse me, a lot of GPR systems sometimes do focus on bells and whistles. The main thing that needs to be focused on is the data quality. So that can be tough if you're not used to looking at GPR data, which like most people aren't. So you look at you might see a system that is full of bells and whistles, and that's the one that you want to use. I think it's really important to test it first, and then get someone who is used to GPR or an expert in GPR to say, yeah, this is working. This is going to add value to you and not become, I don't know, a doorstop. Yeah. So focusing on the data quality first and foremost before everything else.
To add to Mitch's response, so in many cases, it's been a very, what I call pushing freight trains. It's been very hard to try and get some customers to engage in a full subsurface utility investigation. But we've always said that no major project moves forward without a environmental investigation or a geotechnical investigation. So we don't see why there's some resistance to doing a subsurface utility investigation. For us, there's a major turn in recent events. We see states like Colorado have actually made subsurface mapping state law to do remote sensing, to do investigation of utilities and not just rely on digital maps and archival data. And so we already knew that Pennsylvania did have some laws in place for public funded projects. But in recent years, the return of investment is a no-brainer for so many good clients, especially the energy market these days, where we know that making a sustainable grid or making it more robust for the outdated or antiquated facilities that are buried there. How do you do good design? How do you make projects quicker, faster? Because social media, makes it very challenging for some of these asset owners. If you get delayed and problems, everybody sharing that information very quickly. And so tarnished reputations means that people do want to do projects faster. But in many cases on the AEC, on private facilities, it's been very tough to get people. The ASE 3802 has been around for 20 years, but we still see customers that are design engineering firms that have ivory towers that would still prefer not to do a subsurface investigation and carry that risk over. And the projects like we see the Boston Big Dig that went from 6 years to a 22-year project. The light rail in Sydney went from a $2 billion job to a $3 billion job. There's plenty of proof out there that there's a very good reason to use this type of service. And there's a lot of good practitioners all over the world these days that are comparable to what we do, use the same technology and find the same results, where you have high reliability on the documents. You make very good designs because you have informed decisions based on professionals that know what the underground is going to be like when they expose it. And so we see the coming years that it's going to be even a bigger business, and it's going to get more lucrative. We're going to see more practitioners and more investment in technologies.
Thank you. What was the strangest features you found scanning the roads in Boston or anywhere else?
Well, we do find an awful lot of strange things, especially a lot of the old waterfronts. The city has all been reclaimed. So you can imagine what is the waterfront now was actually inside in the harbor many years ago. So you're always finding the old wooden harbor, the piers and the piles. But I think the strangest thing we ever found were some dinosaur fossils on a project in Montana. And so when we're looking at some of the underground imaging and we just don't seem to make any sense of it, we still believe that hydro or air vacuum excavation safely exposes these things. And on that project, it was a pipeline project. They exposed it and they found out there was some old bones in there. So, but we do know there's a lot of strange things down there, but it hasn't been too crazy for us.
How do you incorporate these new costs into project costing templates that developers and engineers use to determine the profitability of a project?
Well, for us, it's been a very, definable cost. So for, any project starts with a topographic survey, and that could be, LiDAR or some of the other technologies that traditional surveyors have been doing. And for us, we actually have studied over the years. I've only been doing it for 39 years, but after studying it over the years, you actually find that doing the below ground survey in a 2D environment is actually very comparable to the above ground survey done by traditional surveyors. So, and the definition of land surveyors in many parts of the US is actually says that you map above and below ground. So that's why we always refer to our industry as subsurface utility mapping, and it's integrated into a survey deliverable. So given that our services, when all combined on a project, we don't even move a decimal point for major projects. So to invest in the underground and understanding the underground, we don't see that as a very big tough decision for a project owner and the AEC community to invest in subsurface mapping because we don't feel it's that expensive and it can be managed. Of course, then what you do is you push it where it can get expensive is all the vacuum excavation and street closures. But most of our work to get that high reliability information in the digital model for the beginning of project, it's not that expensive. And we don't feel that it's an inordinate amount of money to spend to make improvements in project safety.
Fantastic. Thank you very much.